We have the following problem regarding related rates. A man is standing 15 feet from a path. A jogger passes by him at 11 feet per second. How quickly is the distance between the man and the jogger increasing when the jogger is 20 feet up the path? This following diagram shows the problem. Here, the y variable is the distance from the man to the path. The x variable is the distance that the jogger has traveled up the path, which here is 20. And z is the distance from the man to the jogger, which we find using the Pythagorean theorem to equal 25. We want to find d of z dt, which is the rate of change of z. We start this by setting 15 squared plus x squared equal to z squared, because this is the Pythagorean theorem. 15 squared is used here because this is the feet that the man is from the path. X squared is used because it could change as the jogger travels, and z squared can also change as x changes. Now we derive this to get the next formula. 15 squared derived is 0, x squared is 2x dx dt, and z squared is 2z dz dt. We cancel this and we multiply 2 by x, which in this instance is 20. Dx dt is 11 because the man passes at 11 feet per second. Z in this instance equals 25, as we found previously. And dz dt is the variable that we want to find. Now we multiply out the terms to get to the next step. Here we get 440, and 2 times 25 is 50, times dz dt. Finally, we can divide 440 by 50 to find that 8.8 equals dz dt. And now the final and important step is to realize that dz dt is a variable, but the problem is asking for the distance. How quickly is the distance increasing? So we'll need to have units. We write that the distance is increasing at 8.8 feet per second when the man is 20 feet up the path. It's also important to note that 20 feet up the path is when the distance is increasing 8.8 feet per second, because these variables can change as the length changes.